Okay, should be recording. So let me share my screen now. And I'm going to pull up the, you guys can see this, right? Okay. So I just uploaded this updated syllabus to the box. So you guys can open box if you want to read it. The parts that I've changed, I've highlighted in yellow. So this is where we're at right now. We're at this week right here. You can see literally we're at the end of the semester pretty much. We have about a month left. And effectively for this class, we have, including this week, 3-4 weeks left, because I never wanted to make the last week anything important just because of final reviews and that kind of thing. So effectively, we have literally this much time left. And so today we're going to look at a few additional Grasshopper things, and we'll walk through that together. But then, after that, I kind of realized we didn't have much time left for, say, a fourth assignment. And just concerning the fact that a lot of you guys were out for field studies, and now we're out this week for field studies. The scheduling just didn't really play out in such a way where, honestly, you guys probably had time to do anything. So a fourth assignment, in my opinion, is unrealistic at this point. And so we'll simply just end it at assignment 3, and we'll just focus on that. And we'll just continue to try to, create one good assignment 3 as opposed to trying to squeeze in 2 assignments for the second half. So that's kind of the first adjustment. But because of that, this changed the breakdown of the evaluation a little bit. So I'll talk about that in a second. The other thing I'm going to change is this one right here, this visual precedent thing right here. This was, if I'm going to be perfectly honest, this assignment kind of ended up being kind of a flop, and that's on me. I really was hoping that this would just be a quick, fun, easy thing that you guys use as a way to kind of share some fun, interesting precedents. But again, considering the timeline that we have right now with, only a few weeks left, and with not many students, quite frankly, up to the point where, you had shared at least, once 1 week, or, a few, like with this assignment, if things continue to track as the way they currently were tracking, most of you guys would not have been past this class with like anything higher than a C, quite frankly. And I did not want that to happen. So what I've decided to do was I decided to take this assignment here and simply make it bonus points. And so the worth of each precedent that you've shared at this point is a little bit less. But now it's no longer, let's say, put this way, a major requirement of your grade. So if you've shared anything up to this point, they will still count, but they will simply count as bonus points. So this is how basically it plays out in the course evaluation. So the first half of the semester, P1 and P2 are still going to be 20%. So that hasn't changed. The fieldwork session that we worked on for the drone stuff, that's still the same thing. And now the entire second half of the semester is now within P3. So that's now 50% of your grade. And now that seems like a lot, but the actual truth is that actually helps you significantly, because it makes it so that you guys can essentially do well in this class, but with a slightly lower bar to go get through. Because let's put it this way, you can probably do well with, let's say, low level B work or even C work, and still potentially get by with a B, a final grade as a B, because of the additional bonus points right here. My goal, honestly, at the end of the day, was I just want you guys to pass my class. I don't really want this to be a class that you struggle or find as a burden or anything like that. And that's really my goal at the end of the day. So this is actually beneficial to you guys, is this adjustment right here. Any questions? This is the main thing. The first thing I wanted to go over was just this syllabus adjustment, so that we have a better path forward for the final few weeks of the semester. Okay, so that's the first thing. I'll summarize this in an email later. Again, this whole change really is going to help you guys. Again, this actually improves most of your guys' grades in the long run. And so you will honest, my hope is that you guys don't you guys aren't concerned at all with the results of your grades in this class. And so, okay. Now that's the first thing. And then for today's tutorial, I posted a few files in the tutorial data box right here. So there's this 329 Grasshopper folder right here. So everything that we're going to look at today, I posted in this folder here. So there's 2 Rhino files and a few Grasshopper scripts that you can download if you want to follow. A few of these scripts will not work unless you download a few plugins for Grasshopper. So I'll explain what those plugins are right now. If you go to this website here, Food for Rhino, I'll copy and paste this into the chat. Right here. This website here basically is kind of like a depository for a lot of different plugins for Rhino and Grasshopper. And the 2 plugins that we'll be using for this class today is this one called Human, and then this one here called Lunchbox. I'll also copy and paste this one into the chat. So it's really easy to download and install these plugins. Basically, all you need to do is just scroll down here and just make sure you find the latest version of the plugin. So you can just see the date here and then just simply click download. You guys might need to create an account first. So maybe you're going here, you don't see the download button. You need just create a quick account, and then that allows you to download these plugins. So yeah, if you want to follow along, you will need to download that. So I'm just telling you that is right now, so that you guys can get ready and set that up. But after you download the plugin, it will basically come into your downloads folder as either a folder. So I'm going to show a quick example of how that works. I downloaded this plugin here called Pufferfish. We're not going to look at Pufferfish today, but I just want to show basically how to install a Grasshopper plugin. Is that you get a folder, or you just get the Grasshopper component itself, and you see basically this component right here. So the way it works is basically you take all these elements here, just copy them, and then so now we have Rhino and Grasshopper open. In Grasshopper, you go to this components folder. So I go to File, Special Folders, Components right here. And if you click on that, that opens a folder where you kind of have all your plugins. Just basically paste all that stuff that I just copied there. Not all of this is necessary. Like for instance, these instructions probably don't mean anything. Probably delete that. The main thing is this green assembly component right there. And then I believe that should be it. So then all you basically do is restart Grasshopper, and I believe it should work. You might need to restart Rhino. Let me just restart that and see if that works now. Restart Rhino. And that should basically, you should see this thing called Pufferfish show up in Grasshopper once that finishes. Let me just make sure that works. So I restarted Rhino. Let's launch Grasshopper. That didn't quite work. Let me see, what did I do wrong? I might need to do this. Right click on this, go to properties. I might have missed a step in this unblock. Let's see if that works. Okay. If this doesn't work, I'll look into this later and I will do it again. I'll try restarting one more time. If it doesn't work, then we'll skip and move on to the next thing. And we'll create another video about how to, or another thing on how to install these plugins. It's actually, it should not be that hard to install plugin. Sorry, I don't practice these tutorials, so sometimes they just work and sometimes they don't work. Okay, so there we go. Pufferfish is right there. So what I did was I went into the components folder and I just simply right-clicked on it, go to properties, and there was a little unblock thing here. I checked that, and that appeared to have done that. So now you can see right here, there's this little tab here that says pufferfish. Now, again, we're not going to look at that tab pufferfish today, but we're going to look at these two here called human and Lunchbox. So these are the two that I'm asking you to download for today's workshop. Okay, so with that said, let's take a look at our first tutorial, and I'm going to open the let's see, the one called grading script. So yeah, in the tutorial folder, this is one called grading script test 3DM. So if you open that, you should see what we have right here. So what do we have in here? What I've done is I created this base file here. This is the Opelika Studio, and I'm doing the Opelika Studio because we have the Opelika Studio on the call today. So what I did was I basically, if you look at this right here, I created a base file with a mesh of the studio site that you guys are working on right now. This is a mesh that I just imported from Informex. And so let me ask a quick question. Do you guys want me to show you guys how to do that? Or do you understand the basics of how to import an Informex mesh?
I mean, didn't it just export as an OBJ?
Correct.
And yes.
Yes, you know how to do that?
Yes, that seems, I feel like, yeah, I mean, if it's just the same workflow as, then it should be good.
Okay, good. Appreciate that. So basically, the reason why we import the mesh is because we want to have a terrain file that does not reduce the data of the topography in any way. And contours are inherently a reduction of the data. It takes essentially, the whole grid of spot elevations and reduces it to a single line. And so contours tend to be a little bit of a flawed method of representing terrain in that way. A better method is to always represent it in terms of, say, for instance, a mesh like this, which is literally the direct representation of the DEM or spot elevations. So what we're going to do is we're going to take this mesh here. I'm going to show you what other layers are in this file here. There's the mesh. Let me move this to the side. There's the mesh layer. There's a few lines here, which we'll explain what those are in a second. I'm going to turn that off. There's a site linework layer. If I turn that on, you'll see they're just basically these little areas I'm drawing right here that kind of represent some of the areas next to the rail line in Opelika. And then there's this bounding box layer right here, which represents the aerial image that I brought in from the drone flight that we did. And so you can see what these green boxes really are just simply areas next to the rail line that are kind of currently, open land, so to speak. I kind of worked within the back of the curb of the current site, and I did this area right here as well. What we're going to do is I'm going to show you guys how to basically take this area here and grade inside of that curve and, like, say, for instance, draw a path and grade that. The method that I'm showing to show you guys is a simple method of grading that utilizes the basic procedure of grading, but just doing it digitally. And so whenever we grade in practice, the first thing that you need to establish for a grading plan is the grading limits. Basically, where does the start and end of the grading plan happen? You don't grade everywhere. You always have to you literally the grading plan, if you think about the operations of a construction site, you have to set up a fence, or you have to set up a boundary of where the construction operation literally begins and ends. And a lot of times, let's say, for instance, on projects like these, they'll say grade from the back of the curb because they don't want to move the curb. They just want to grade simply within that area there. So these are literally our grading extents. And so anything we do in terms of a grading plan needs to meet the perimeter elevation of whatever that is right there. So this is all in 2D. You can see this is all just basically flat in 2D because it's just what we want to do is we want to have a very simple flat base that allows us to easily draw these boundaries. But then project that into the 3D space. Okay, so with that all set up, let's go open Grasshopper and then open the thing called grading script. So in the folder here, there's a thing called grading script.gh. So as a way to hopefully make it easier for you guys to learn Grasshopper, instead of what I did last time, which is just to write the script step by step in front of you, I'm simply now just giving you the script. I kind of wanted to avoid doing this because I wanted you guys to learn. But at this point, it's maybe I'm going to try a different technique, which is to just give you the script. And so I give you the script. And if you zoom in here, this is a method that, I've seen done before, is that basically I give students a script and I simply write out the instructions for each component. So you can just follow along 1, 2, 3, 4, 5, 6, and just move along. It makes it a little bit more of a passive way of learning it, but it also just might be a little bit less confusing. So let me explain how this works, and we'll just walk through the whole script together. Again, this script does not work unless you have downloaded. Actually, no, this script here does not require any special components. This one here just uses basic Grasshopper components. So step 1, set your mesh down here. Sorry, I need to grab a drink every so often because so this here, this basically is you go to set one mesh and then you set this mesh here, the mesh on the mesh layer. And so if you've downloaded the Grasshopper script and this Rhino file from the tutorial folder, it should already automatically set that in there. But that mesh there just represents basically the raw terrain data. I'm going to select that and hide that. Number 2, these are going to be the curves that represent the grading extents or the grading limits. So you see when I select this here, you see these curves here. Those flat 2D curves are selected now. And as long as they are closed and planar, this will work. So those are those curves right there. So again, just set multiple curves and you can select as many as you want. So turn that off there. The next thing we need to do is if you follow like what's happening here, this grading extents curve that's being brought into this section right here. What we're doing here is we are taking those curves and we are extruding it vertically and then capping that. So extrusion and cap. And what we're basically doing is we're creating these trim boxes. So this will come in handy for when we need to trim our contours when we finish our grading plan, because we want the contours to essentially trim inside of the extents box. So this rectangle here just allows us to do that. So if you say, for instance, move to a different site, you will just simply take this grading limits box height and just make sure that it's high enough that it intersects with the grading extents mesh. So that's that. Move down here. So all this stuff here that you see here, this here is just a long script that allows us to take these curves down here and project them to the mesh. So in Grasshopper, as far as I know, there is no, let's say, for instance, just project to a mesh function. There is a project to a surface function. And so all these things here, essentially what they're doing is it's taking these curves here. It's segmenting that curve into a series of points. That's what these things here do. Oops, let me turn that off. And then it's merging those points together, sorting those points in the order along the curve itself, so that basically it has an order along that follows the length of the curve. This here basically removes any duplicate curves, duplicate points. And then that is projected vertically onto the mesh using this here. So this tool here allows us to project the points directly on top of the mesh using a Z vector. So that's what you see right here is basically these curves are now being, their vertices are now being projected onto that mesh there. And then these points are reinterpolated into a polyline using this right here. So all this stuff here, all these components here is doing the task of taking these curves and projecting it to the mesh. And so this line here represents your grading boundary, but now it's actually in 3D. Let me turn that off. And you can kind of see like this is the end result of what we're going to do. We'll talk about that in a second. Okay, so that's kind of the first step, is to get to this point here. But then let me zoom out and turn off this stuff here. But then, and I apologize. I know this is probably really confusing for those of you who still learn how to use this tool. If at any point things don't make sense, just yell out, "This doesn't make sense." Like I'm happy to try to make it more sense. It's better to ask the question than to just not ask the question and wonder why things are happening. But basically, what we need to do, and what I'm doing with this section right here, is that's where these curves here come into play. So those curves right there represent the center line of a path that we're drawing within this space here. So what you can do here is you can set a couple of curves that represent the path. This is very similar to what we did a few weeks ago, where we set those little vertices and then interpolated a curve for those vertices, and then basically turn that into a path. This is a similar method. But what we're doing now is we're taking that curve, we are smoothing it out using this fillet right here. So now the corners of the curve are no longer angular. So that's what the fillet does. And of course you can adjust this radius here or this distance here to make it smoother or less smooth, depending on what you want. And then right here, this is where we take the curve and we offset it based on a width. So right here, you can see this is path width right there. So right now it's set to 12. If you want, you can set that to be 10. And again, our model is in feet, so that that's what this unit here means, is feet. So what this does is it takes the curve and offsets it into two sides like that. And then it lofts them together. So it's very similar where the script that we worked on a few weeks ago. And then the finished surface here, what we do is we take that finished surface and we subdivide it into a series of points like this, using this tool right here. And the reason we need to do this is because we need to take these points and we need to use these as essentially as spot elevations to interpolate contours from. And I'll explain what that means in a second, but basically all you need to do is you need to take this surface here and you need to turn to a bunch of spot elevations. So all we need to do is just use the divide surface component to accomplish that. And then down here, this whole group here, like I just put a giant explanation here, this whole section just visualizes the slope of the path. So literally all this does is it basically allows you to just see, along the path, that you're drawing, what are the actual slopes. And so this is a good way to verify whether the path you're drawing is within the correct ranges of slopes that you need to do to build a proper path. Okay, so let me move this to the side here. I've kind of walked through this first half right here of the script. Am I not making sense? Is this really confusing to you guys? Or do you guys want to see the rest of the script?
Do the rest.
Okay.
Or
4? Is that what you said?
more.
Okay. I really cannot tell if you guys are confused or not, because I just, this stuff, unless you really have played with Grasshopper, it won't make any sense unless you know what these mean. I feel like I'm confusing you guys. I apologize. Okay, so I'll do my best to explain it. So basically this whole half here, what we've established is a few things. We've established a path, right, that we're moving through this this design, and also a gradient extents, right, like so. Because what we need to do is we need to take these two pieces of data, this path here and this gradient extents, and we need to interpolate contours from that. That's essentially what a grading plan is, essentially like a design and a gradient extents that you interpolate contours from. And so I like to teach grading this way because it fundamentally takes the whole idea of moving contours and doesn't make it an issue. It just makes the design at the forefront of the conversation, because contouring and grading is simply a result of a design concept. It's not the design concept, if that makes sense. And so you just need to have a clear design concept for this to work. So we're going to take these elements here, so this curve and that, these points here, and what we're going to do, let me show you what's happening, is these two are kind of converging together into this section right here. You see how this curve is coming here? This curve, we basically have taken two worlds. There's this bottom half, this top half, and we're converging it into one thing. And that's what we're going to do here. So the top curve here, this is the gradient extents. What we're doing now, let me zoom in, move this over here, is we're taking that and we are exploding it. If I turn that on, now we are extracting out the control points or the spot elevations of the perimeter of that, right? Turn that off. And then we're taking these points here. We are using this tool here, this component called point in BREP. What this allows us to do is allows us to cross-reference these points with these trim boxes, and it allows us to organize these points into its respective box. So at the end of this whole process right here, what we have essentially done is we've used this process to take these points here and organize them into one of the boxes. So you can see I've only drawn, I have 5 of these set, 1, 2, 3, 4, 5 of these grading limits. And so there are 5 branches, but I only drew a path in 2 of them. So you can see that it organized the points into 2 of them, right? So like so.
Are the boxes you're referring to the grading extents?
Yes,
Okay.
grading extents. That's what these 5 here represent. Now, before I get even further into this whole thing, this whole thing that I'm describing right now of like organizing data into these branches is the secret to learning Grasshopper. It took me personally, I would say, about maybe a full semester at Harvard, working on Grasshopper projects for literally a semester straight of understanding this thing of organizing data. My point being this is that, again, like I keep saying, you're not going to be able to learn this tool in a weekend. just you need to play around the tool and just get used to it and mess with the data. And you'll learn and you'll get it eventually if you play around with it. If it doesn't make sense today, it won't make sense unless you mess with it later. But organizing data and doing things like this that I'm showing right here is the secret to learning Grasshopper. But essentially what we're doing now is we're taking these points here, these points, this point, and that point, and now we're merging them together. And then we're going to use this tool here called Mesh, and essentially takes that whole process and it meshes it all together. Let me turn off these points right here. I'll leave this one on. So it's taking that and it's meshing it together. And so this is the end result that we want to go for, is this mesh here. So this mesh here, what we do, let me move to the right. You see that, follow that line there. We contour that. So there's a tool called Contour. Let's turn the preview. So that's the result of this whole process, is that we basically taken the gradient extents here, the path that we've drawn, and we've contoured that, because it's just taking all the spot elevations and it's interpolating them together. That's all grading is interpolating spot elevations. And then the final step, you can see that this is fine, but there's all these like extraneous areas outside of the gradient extents. The reason that is happening is because meshing is not intuitive. When Grasshopper is looking at these points there, it's simply looking at the triangulation of points and doesn't really know where the triangulation starts and ends. So as a result, it's meshing outside of the trim box. What this means basically is we need to take these curves here and we need to trim them using the trim box or the gradient extents. So you see that gradient extents box that we set in step 3, that's coming back right here. And what we're doing is we're taking that and using this component here called trim with a B rep. And then we simply trim those curves. So now if we turn off these contours here, these are now trimmed right here. So that's the end result of that process. So let me turn off everything in Grasshopper. You see essentially what we've done is we've taken the whole design aspect of it and we've simplified it into simply just 2 things. Number 1, where is the extents we're grading? And number 2, what are you grading? And then Grasshopper does the rest. And so in action, this is what happens is essentially, let me go to here. Actually, let me do this as well. Let me, bear with me. I know spinning around the model is annoying, but let me go back here and turn on these edge curves so you can see the edge of the path. And then you can go back here and show you this and what's happening. Let me turn on the, actually, let me do this as well. Let me turn on the slopes as well. Okay, sorry. So now essentially what you can do is you can look at this path here and you can adjust it on the fly. And that's a nice, nice intuitive way for you to adjust the path of your design and see how that path, depending on how you adjust that slope, fits within that gradient extent. So let's say you want to just think really dumb and like create a giant mound like so. You can do that if you want. Obviously you won't do that because you're essentially creating a 20% ramp this way, but you know, the whole point of it is this, is that, you know, what you need to create for yourself is a way to design freely and intuitively. And that's why, you know, the whole beginning of this whole process said Grasshopper, if you master it, it feels like hand drawing. If you don't master it, then it's confusing. But once you've mastered it, it allows you to like design freely and intuitively. So you can literally look at this and say, okay, well, you know, I'm designing this path here, but you know, you're creating a lot of like steep slopes here. So maybe you need to take that and move it down a bit to even it out a bit. So that's essentially what the whole process of that path is. And then obviously, you know, you can go back into this and say, okay, well, go back to a previous step, path width is 10. Maybe you want that path width to be 14. So you can go back and you can adjust that. The last thing we'll do with this script here is what you can do is at this step right here, this is the last step. You want to take the rest of the contours for the rest of the mesh here. Let me turn this, enable this first. Let me show you what's happening. This after I enable, you can see how it's thinking in the background. There we go. This contour here, what it's doing is if I turn it on, it's contouring the whole mesh, right? This is literally, what you would get in terms of contours for, if you cut contours from the mesh, literally. And so you can see like this is the existing grade. So what you can do is you can take these contours, you can use that same trim thing that we used previously. Let me enable these guys. Instead of trimming the inside, you can only, instead of keeping the inside contours, you can actually only keep the outside contours. So that's what this is right here. So the end results have this whole process. Let me turn off this line here, is essentially your path graded within the context of Opelika. So that is the grading script all put together. And again, the whole point is that at the end of this whole process, you have let me go to a plan view. You can just design freely, and you don't have to. You can even look at this and go, okay, the grading extents here. Let me turn on the aerial image. The grading extents here. Maybe you want to change that, so you can change it now. So you can adjust the, say for instance, the grading extent. So if you move this, say for instance, point back here, you see what happens essentially then. And just like this area here is your existing grade, and it's like pushing the areas that you're actually adding fill to. Or if you want to move back, let's say you want to do something really dumb, you want to like grade into the path of the train, you can do that. I wouldn't recommend that. I wouldn't recommend that, but the whole point is that you just want to make this intuitive and fun. So I encourage you all, and because you're Studio Opelika, I've given you Opelika, and I've given you this grading script. And so you can play around with this now, and you can play around with the idea of creating a greenway or a path. I know some of you have like bike trails and things like that. You can even take this and you can modify it to, I know like Vera, you have a water feature. You can modify this to do that, to add that to your thing. Okay, that's script number one. It's done. So play around with it. Again, you have everything you need. Just download the script, download this Rhino file, and you can play around with it you don't need to download any plugins later. Yeah, that's it. Okay, let me close out of this guy. And let's see, it's 8:41. We'll take a break at 9 a.m. So we may have time to introduce the next script. So we'll introduce one more script, and then we'll take a break at 9 a.m. and then we will continue with the rest of this. So let me open, sure, I'll save this. I literally wrote this grading script last night. So this is me just sitting there thinking about how to do that. So Rhino Grasshopper tutorial is the next one. So I'll open that guy. And in here, I have a few scripts that we're going to look at. So abstractly, I'll explain what they are. One thing we're going to do is we're going to look at a planting plan script. Let me do this first. This is let me take these curves here and move them to the side and delete these guys. So I'm going to show you a quick way to make a planting plan using these curves here. That's script number one. Script number two, we're going to show you how to take Enscape blocks or any block in general and distribute them, along a path so that you can like easily, say for instance, like begin to model a landscape. So that's script one. We'll look at this right now. The second one we're going to look at, this is specifically for Trey. You want to look at how to create a paved path that follows the directionality of the path itself. We'll do that. Then last one, this one was specifically for Hannah, but I'm not exactly sure if this is going to be totally relevant, but there was a request for a screen wall. So I'll show you one example of that. Really, a screen wall design can manifest itself in many different forms, but I'll show you guys one of that. So this whole thing is basically going to be a few different things. The planting plan I thought would be more universally relevant to you guys, because you might design a planting plan as part of your studio projects or not. I don't know how detailed you'll get.
We are.
Okay, so let's get into that. So let me open Grasshopper, and let's see. The next script we're going to open is going to be planting blocks. So open that guy, planting blocks. And you see, this is what you get. So again, I'm writing the script for you guys, and I'm putting the steps in there so that, because I know you guys don't follow along when I demo it for real. So instead of, you can follow along with the video, but you can also just follow along with the script. Maybe this is maybe this is the superior method of teaching Grasshopper, is just to give you the script, just give it to you guys, which I'm kind of like, I think is a little bit cheating, but whatever. All right, so we're going to focus on the top half first. So let me do this. Let me actually let me just do this. I'm going to take this whole section here. I'm going to make sure it's preview off, and then I'm going to disable this one for now. Okay, we'll go from left to right. All right. So step one, set curves in Rhino that intersect to create a planting hatch area. So here's what I mean by that. Let me show you these curves here. Whenever you design planting plans, it's usually very loose. It's usually very, it's not super precise a lot of times. A lot of times you're kind of like drawing areas of certain groupings of plants and areas of other groupings of plants. And you just need a very quick way to, adjust that. So I'm just showing you this method here so that you can like easily design a planting plan without having to like get so anal about how it works. But basically just draw a bunch of curves like you see here, and they intersect with one another almost arbitrarily. And quite frankly, with planting plans, sometimes that arbitrariness is ideal, because it's more of a feel through the design rather than a precise design. You can have a lot more fun with planting plans than with any other elementary design. So I'm just drawing a bunch of curves here that intersect with one another. So I'm going to set those curves in this layer here. So I'm going to choose set multiple curves, choose all those curves right there, and hit enter. So now they're set in Grasshopper. So I'll preview, turn those off. So what we're doing right here in this section right here, without getting to every single thing, what we're basically doing is we're taking these curves here, and we want to extract out the areas that are closed within it. So anywhere where there is a closed area in there, everything that's going on here, essentially what's doing is it's taking these curves here, it's creating a bounding box around everything. It's taking that bounding box and it's creating a larger box around that. And then it's taking that larger box and taking these curves and simply trimming the surface. And when you do that, you get let me turn off these curves here. You get something like that. You get that's what happens when you trim the surface, is that like the little areas that are overlapping or extending beyond the surface, they just kind of go away. And then you can take this here. If you can cull, which basically means remove, you can remove the first index 0, because this method always has the first index, the first element. The first element is always the largest surface, and the largest surface is always the one that's on the outside, right? This one on the outside here. So if you just simply remove the largest index, now you get basically the close boundaries. So what does that mean practically? It means practically, you know, you have a curve here, you're gonna move that around, do whatever you want. Think of this as like Insta-hatch tool, where you basically allow you to just draw curves randomly and then just Insta-hatch it. That's not a word, but I created now Insta-hatch. So with these curves now, let me turn those off. What we do is, let me enable this guy, is we turn those hatches into simple surfaces like so. And then what we do is, I'll get into this whole thing in a second. We'll get back to that. You see all these sliders here and they look very scary. It's actually not that scary at all. What we do is we take all these surfaces here and we need to do this whole process of creating essentially a triangulated grid within each of those surfaces. And so without getting too much into this stuff here, essentially what we're doing is we're just inside each of these surfaces, you're just aligning some kind of triangular grid. And that triangular grid is scaled to basically match the extents. And that's what all these formulas here are here for. And you're looking at this go, Frank, math, that I'm allergic to math. Blah, blah. Well, okay, stop complaining. It's not that scary. It's just a little bit of math. Basically what we need to do is we just need to, understand, in order to create a grid of triangles within this area here, you just need to understand, like, in this direction, that direction, how many rows of triangles is required to fill that square in. Because, the triangle, width in this dimension and that dimension are different, you need to create a specific formula to accomplish that. That's all these here are for. This is literally me. This here is me with my sketchbook and drawing triangles in my sketchbook, figuring out like what is the formula to figure out how to like take the length and width of a rectangle and fit a bunch of triangles within. That's all it is. And you can do that too. Okay. And then essentially what you do is you take those triangles and you extract out the corners. So you see what we're essentially doing is we want to create that triangular grid that is typical of planting plans. We typically like to, show the organization of plants in a triangular grid. Okay. What this stuff here is we need to establish, let me do this first. Let me disable that. We need to establish the size of the spacing of the grid. Let me go to the top view. So that's what these sliders here do, is essentially, depending, let me move here, because I'm press bar somewhere else. We need to say like, how much are each of these, how far apart are each of the plants in this area? So that's what these sliders here are trying to accomplish, is simply changing the spacing of each of these grids. If we say, for instance, add another curve, we'll get back in a second. Basically, that's what these sliders here do, is that it changes the spacing of them. So, and then the most important thing is that the number of sliders here needs to match the number of branches that you have. Literally the number of planting hatches or planting boundaries that you're creating. So if you add one more curve in here, you're creating a few more planting areas. Therefore, you need to add a few more sliders. And so what you essentially do is you go in here and you add a few more of these inputs, and then you add a few more sliders to do that. It's a bit of a manual process, but this is simpler than creating a more automated script. Let's just put it that way. Okay. I've probably confused you up to this point. Let's just get to the fun part. Okay. So we take these points, right? Take these points here. And then what we need to do, let me end this, disable that guy. We go to this section right here. And then what's doing is it's taking the points and it's simply looking at these points here and saying like, okay, so there's a bunch of points that are outside of the boundary itself. We just need to tell Grasshopper to say like, all right, if it's outside of the boundary, remove them. And so that's what this whole process here does. At the end of this here, it just simply takes that and it removes those points. Again, I'm kind of going over this real fast, basically, but what it's doing is, number one, well, what's doing here is it's removing any duplicates. Then number two, what's it's doing is it's searching within each of these boundaries. This is the boundaries of the planting areas. It's looking for whether it's inside the curve or not. So that's what this command here does, point in curve. Test, you can see the description, test a point for closed curve containment. And then that gives you a Boolean, which you can use to cull the data set. And I just used two words there that may or may not have made sense to you guys. But again, practically all you care about is the end result, is that this is what you get, is you get a way to modify your planting boundaries and have a distribution of points inside that planting boundary that adjusts with the size and shape of your lines there. And these lines can be curved if you want to, like they don't have to be straight. Okay, but then what you do is you take these points here, and then all this stuff here, what it's doing now is it's beginning to turn them into plants. So what we're going to do is we're going to take these points here. Step 6, this is not a necessary step, but it may add interest in design to randomly split the planting area. This component accomplishes that intent. So what we're doing here, let me turn on these points right here. What it's doing is if you move the slider, you see what it's doing is it's randomly splitting it into two lists, or you can think of it as a random reduction. Maybe you don't want your planting plant just be a giant block of plants. Maybe you want there to be a little bit of interest where there's like groupings of plants and groupings of other plants. So what I do is I just use this random split here to basically create groupings of plants, and then the rest we'll just simply put a very generic circle there and just call that infill planting, right? So then what we do is we take these points here, these ones right here, not these ones, let me turn that off. These points right here. Then what we can do is these points go right here. You see that follow line. And then what you can do is you turn on these guys right here. All these are doing is just simply drawing the circles that represent kind of like the planting circles, right? And so these represent these circles here. You can see that radius right there. If you follow that line goes all the way back to here. Remember that these sliders there? So these sliders, if you see what it's doing essentially is that it's taking the circles and it's just simply making them bigger or smaller. So you can have larger planting blocks, smaller planting blocks. These are all in feet, so you can use that to adjust the sizing of these blocks as you go. So this goes back all the way, goes all the way back here. So that's what these circles here do. This step here is not necessary. Typically that's enough, but sometimes when we do to differentiate the blocks as we put a little like shape inside the circle, maybe it's like a hexagon, maybe it's a diamond, maybe it's a triangle. It just makes it a little bit easier to differentiate them. So that's what this here does. And then sometimes what we do as well, in order to make the planting plan a little bit more legible, is we like to put a little line between like blocks, like so. This may not be necessary. Maybe this is actually too confusing, but this tool just allows you to like take basically searches these points and just finds like the closest point and then draws a line between them. That might be too confusing. Maybe this is enough. So that is the first step, and then you can turn on these infill plantings to kind of get that. All right, but then practically speaking, this is the result. Is basically you can take these lines here, you can adjust your planting boundaries based on your design. If you add a curve in the middle right here, and then you go back to step 1, set multiple curves, add more curves to that, it will not work. What you need to do is you need to go here. See, you have 9 branches now. So you need to add a branch 8, copy and paste that. add a branch in 9, and now it works. So that's what this step here is for. And you can adjust the sizes of them like so. And again, you can adjust this. Again, like I said, these do not have to be straight. You can add an edit point into it. And so you can do something like that. This can be curved if you want as well. So so you can do that. Okay, the last thing we'll do, and then we'll take a break. So you have all these circles here. Let me go back to this step here, these locations. Let me turn that off. These points here. What you can do is you can place a block onto each of these points right here. And so that's what all this pink stuff here does. So what we're doing is we're going to take all these points here. We're going to create a translation vector, a series of transformations that allow us to place blocks onto each of these points. So all this stuff here, and I'm sighing because like I feel like I've lost you guys, because again, I don't know if this is not making any sense, but all these things here basically creates a transformation vector, a series of transformations that allow you to take a block. Blocks are usually oriented at the origin and move them to each of these points here. So all this stuff here, you can see what it is. Essentially, it's moving something from the origin. This is the origin point right there. Moving it, that's what this one here, moving it, rotating it, because we want these blocks to have a random rotation to them, and scaling them. Scaling, you can see a scale range of randomization here, so that when we place a block onto them, it has a bit of randomness. So right here, this is the only portion of the whole script that requires this tool called human, this plugin called human, because what this plugin allows you to do is allows you to bake blocks into Grasshopper. So what does that mean practically? It means, for instance, if you put an Enscape asset into Grasshopper, like say for instance these blocks here, these are all blocks. So if I click on this block and go to the properties window of Rhino and go to details, you can see all the details about that block, including right here, the name of the block. This block is called Bush 118 Lavender. This is an Enscape asset. So what I do is I take that name of the block, I copy it. I'm just using that one as an example. Let me move that to this side here. And what you can do is you can bake it. So this is that Bush 118 Lavender. Basically what I do is I create a panel and I paste it into the panel right there. Then you plug that panel into the name of the block right there. Then if you push that button right there, it will bake that block to these locations. So I just push that button and they just instantly populate that. So let's open. I just undid that in Rhino. So if you open Enscape, what it allows you to do. Let me zoom in here. Oops. If you bake that, allows you to, basically populate your planting plan instantly. So it's a very nice way to like take your idea and just visualize it real quick. You can see this is where this whole randomization scale 0.5 to 1 comes into play right there. That's why you see these blocks kind of like some are smaller, some are larger. It adds that little bit of randomization to the design. If I undo this and go to this randomization here and just say, for instance, make it 1 1-to-1. Like there isn't basically no scale range, is all 1. Then I bake this. Now they're all the same size, right? So adding a little bit of randomization to the planting blocks helps the visual of it just be a little bit more realistic. So again, I'm gonna go back in here, undo this, maybe make it something more subtle like 0.8 to 1.1, and bake that. You can see that's the result. It's a little bit nicer. All right, that's it. So let's take a break, and then we'll go on, look at some other parts of this script. So it's 9:03. Let's meet back at 9. A 10-minute break. So 9:13. Let's say 9:15. All right. See you guys. All right. So when we wrapped up, we finished this upper half right here. This planting plan thing here. So you can play around with that. A much simpler version of that script is down here. So what this allows you to do is essentially use the same block transformation thing that we showed you here. That's the pink right here. But instead of going through all that trouble of basically creating a grid like here and these closed areas and distributing a bunch of points in there, what I'm showing instead is you could just simply take a bunch of curves. Like here, I'm just showing these 4 curves. So if I set those curves in here like so, you could just simply, create a grid of points from those curves. So that's all this is here, is just taking the curves and just, creating a bunch of points. And as long as you have points, you can distribute a block on that. So what we're going to do with this section down here is we're going to distribute a tree block. So this is a tree block. This is a tree block from Enscape. So again, we're going to use this whole thing with this randomization, rotation, all that stuff here. And if we bake that, you see what it does is that it allows you to, just with a few simple curves, allows you to distribute these tree blocks onto your site. So maybe, for your design, you just want to have like a simple row of trees somewhere in your model, and instead of like copying and pasting it multiple times and going through that trouble, you can just simply draw a line in your model and then just distribute it like so. So that's the end result of this whole process. And again, the randomization and rotation, what that does is it's one second. Sorry, my computer froze. Are you guys seeing everything? Okay.
Yes, it's moving, or at least Enscape was moving.
Yeah.
Got some glitchy movement.
Yeah, the frame rate's slow, but it's at least moving.
Yeah. Hang on. Dang it. Sorry. It's hard to explain what's going on my side. Basically, my mouse froze, but let me see if we can get out of this. There we go. That did it. All right. Sorry. I really apologize. This is probably not the most fun tutorial, but basically, that allows you to, with a few simple curves, like we show here, allows you to, create the grid of trees, say for instance, you want to do that. Or, if I undo this, again, the whole point of this whole method is that, you can, have fun with it. You can play around with the design. If you, have something else in mind that you want to do, that just allows you to very quickly adjust that. Maybe say, for instance, you want the spacing of the trees to be a bit more dense. You can make that 15. And that increases the density. Maybe you want the randomization of the trees to be a bit more drastic. So maybe it's going from 9.9 to 1.5. So now the tree sizes you see here are a lot more varied. the whole idea is that design should be fun, and you should just enjoy the process of thinking creatively how to make space. And you shouldn't have to get too bogged down with the technicalities of how things. You just need to come up with ideas and visualize it as quick as possible. So you know, just being able to easily organize your trees on site, and then also be able to place them in a way, such a manner where they are somewhat randomized. You can see how the rotation of the trees here is not copy and paste, copy and paste, copy and paste. It just makes it a little bit more natural looking. So it's a very efficient way to do that. So that's what this bottom half here is doing, is basically just allows you to quickly create those blocks. All right, before we move on to the next one, again, any comments or questions on any of the stuff I showed you guys in this particular script here?
Maybe you cover this, but like, I don't know if we're talking about this script or previous script, but with the plantings you did that were the first planting you did,
yeah.
Is it easy enough to, instead of using those crossing lines, to just make a like a amoeba, a closed curve, and do it inside the closed curve? Is that easy enough?
Yeah.
Okay.
So I'll show you another way you can do this. So what you're describing is maybe like a more of a, like you're saying, like an amoeba shape like this.
Yeah.
Right. Yeah. What you can do is you can take a thing like this, and in Grasshopper, let's just write, this is a script you can write. You can take that curve there, you can set that curve, set one curve, right? So it's in there. You need to take that curve and you turn into a boundary, surface. And a way to create a surface out of a curve is just to use this thing called boundary surfaces. Then all you need to do, you know, the whole process of going through this whole thing is you just need to create points inside of that area there. And there's a few ways you can do that. You can just use like the divide surface tool here, where you see that just like creates a grid of points. You can also delete that guy. You can also use this thing called populate geometry. So this one's a bit more of a naturalistic thing here. So it's not like a grid, it's a bit more of a random. Maybe this is a bit more appropriate for an amoeba shape like that. Yeah. This allows you to say right now there's 100 points in there. You can say, for instance, put a slider in there and adjust that density a bit. Again, what you can do is, you know, let me see if I can do this real quick. If you do the random split right here, and then we'll do is we will put a slider in here, and then a geometry component right there. What this allows you to do, this allows you to take that list of points there and allows you to just create a bit of a random grouping. You can see how it's like beginning to like remove some points, maybe make a nice dense grid of points like that, and then remove a few like so. And then what you can do is you can use this thing called proximity. Then as long as the G here is 1, it creates like these little groupings of curves here, like you see right there. And then if you put a circle, you know, in those there, it's just, that's like essentially a planting plan right there. If I go to a top view, let me turn these off. Essentially, like you need a grouping of plants and then a way to relate the plants with one another with like a little line like that. This is a bit more of a random design. Again, if you want to do something a bit more of a regular, you can do a grid like so, and increase that density and play with that.
Cool, thanks.
Okay. So I'm gonna close this one here, and then let's go open the next script, which is this one called Curving Paved Walk. So that's this one right here, Curving Paved Walk. That's the one that we've downloaded here. This one requires Lunchbox to work. So if I zoom out here, this is the end result of that whole process. If you kind of remember back when we visited St. Louis, you know, we had that little walking garden at WashU. This is kind of similar to that. There's many projects like this you see in landscape architecture of these very nice garden paths that kind of have this nice curvilinear walk, and then the paving kind of follows the path. So I'll show you how this works. Let me turn off these here and we'll walk through the process of this little script there. So it starts with a simple curve like this. So this is the same thing that we did with the path, is that we just need a path that represents the center line of the walk that we're doing. That curve, again, what we do is you put a little fillet on there. So that does, it just takes the corners and just round them out. This is just a nicer way of like rounding out the corners of a curve, is to just use a fillet, because then you get a nice even radius as opposed to like a blobby spline. That's what this here does. This section here, so you can see this fillet curve, what it does is it now is feeding into these offsets right here. So again, this is very similar to the paving, the path script that we wrote a few weeks ago, where we just offset it on both sides by a distance. And so right now we're doing an 11-foot path. You can change that to, say, for instance, a 10 if you want. So that narrows that a bit. So that's what this is doing right there, is it's just taking those two curves and creating that offset. This section right here, so you can see this fillet is going through here and these curves are going here. This here, what it's doing is it's taking the center line of the curve, it's dividing it into a series of points. And it's taking those points and it's basically pulling it to the either end, both sides of the offset curves, like you see right here. So it's taking, say, for instance, this point, and it's pulling it to that curve, and it's pulling it to that curve. Typically, the shortest distance between a point and its offset is a perpendicular line. So this here is a perpendicular line from that point to that point to that point. And that's what these pull points are doing. Because what we want to do is we want to create a perpendicular line along the run of this path here, because these perpendicular lines are used to make this network surface here more even. Let me explain what I mean in a second. Let me turn this off, disable that. So what this network surface component here is doing is it's taking these perpendicular lines in as the V input. And then the U input right here is the two offset curves, like so. If we did not have any of these perpendicular lines, let's say this was like 1, for instance, and I bake this, let me bake it. Yeah, just bake it. You see how the topology of this geometry, like these lines here, look really awkward in these really tight corners there? That's because, again, Grasshopper and Rhino, it lacks intuition. It doesn't know exactly how a loft or a surface needs to be. It needs more information to help with the generation of that surface. And so these perpendicular lines here, the more you add, let's add, like, say, for instance, 6, that improves the generation. So I added just like 6 there. You see that it's beginning to be a bit more logical. But then we say, for instance, add a few more. Let's add, let's say, like 58, and bake that. See that now, like, the directionality of this path makes a lot more sense, right? You can see how the edges and the alignment of these UV axes makes a lot more sense. That's why we need to do this step here, is to basically make a path that is cleaner, because this surface here, this surface is what we're going to use to create our pavers. And we want the surface to be as even as possible. So this slider here just allows you to basically get a more precise, even result. So let me disable this guy here first. This component right here requires Lunchbox. So Lunchbox is a tool, a plugin for Grasshopper that has a few very nice paneling options right here. So you can see you have diamond panels, hexagon panels, quad panels. What we're using for this tool here is the Staggered Quad, which is basically a running bond pattern. So if I enable this guy and turn it on, you see what it does is it takes that path and it generates a running bond on top of that, using this network surface as the guide for that. If this network surface was built using a really bad reference surface, you can see, like, I move this curve back, you can see how the dimensions of the pavers begin to look really off. That's why this section at step 4 is required, is to basically make it so that it's a lot more even. So I'm going to set this, seems like, you know, around 50, 60, it seems to be the best result. So that's what this is here. Now, this U and V value here for this quad component here, let's go back a few steps. Let's go back here. This section here allows you to establish the paver length and the paver width. So all it's basically doing is it's taking the length of the center line here and it's dividing it by a certain paver length. And that gives you, you know, an average paver length. Obviously, if I zoom in here, you can see, like, the pavers on the outside are longer than the pavers on the inside. And that's just due to the nature of a curvilinear path. You can't have this an exact paver size across the whole thing. Some pavers are going to need to get cut for this to work. So this more represents an average paver size, 24, as opposed to an exact paver size. And then paver width, what it's doing is basically taking the width of the path right here and dividing it by, in this case, 1. So it's basically we're having is a 1 foot paver. So it's 1, 2, 3, 4, 5, 6, 10 feet. That's what this represents. So if you wanted to say, for instance, right now it's a 2 foot by 1 foot paver at 24 inches by 12 inches. If you want to make it say, for instance, a 4 by 8 paver, what you would simply do is take the paver width here, make that 4 inches. You can see how that's instantly changed that. And the paver length here, that can now be, like, say, for instance, 8. See, that changes that. So this feels more like a typical brick paving pattern now. For the purpose of this video, I'm going to make a larger paver size just so that it runs faster. So let's make the paver length 24 and the paver width 12. So a 1 by 2, 1 foot by 2 foot paver, which is a pretty nice big paver size. And again, you know, I can go back in here, can adjust the design of the path. Maybe you want to have nice little nooks and crannies in the design. Again, just a way you can design like these fun little spaces, but not have to worry too much about, like, the actual details of it in terms of, like, laying out the pavers. Okay, so let's move to the next portion. So we have this quads here. What I'm going to do now, let me turn off this, disable this guy, and enable this guy right here. What this here does now is it just offsets the pavers by a little bit. You can see now there's a gap between the pavers. That creates the joint between the pavers. So in this case, I just offset it by a 1/4 inch. That's what this number here represents. So that just gives a little bit of a more of a, you can almost think of this like basically like just, you know, laying the pavers out so they don't overlap with one another as best as you can. You can see that they are actually rectangular pavers, or rather quadrilateral pavers. They're not exactly rectangular, but you know, that's kind of what this is. It was doing right here. And then you see right here, for instance, like these pavers here are skewed. Again, the way to fix that is to try to increase the number of these here. See that fixes that. So that's a little bit less weirdly shaped like so. So then what you do is you take these pavers here and then usually apply a pattern to it. So this could be the end of the whole process right here. This just right here, just that's it. Everything we're going to do after this step right here is just you being creative with Grasshopper. It doesn't matter how you create a paving pattern. So I'm going to show you in this instance how I created a paving pattern for this. So what I did here was I created a simple series of attractor points. So this is the Attractor Curve script where you basically create a few points in the script in the model here. And then what it's doing is it's calculating the distance of each of the pavers from each of these attractor points. And so that's used to essentially create a list of numbers that you can use to organize these pavers. So that's what this section 10 is for. Then this section right here, what it does is it's taking those pavers, it's adding a little bit of a jitter to it. That's what this here does. So the jitter adds a little bit of randomness to the pattern. And then splitting it via some random index. And that index is determined by this slider right here. So what does that look like? Let me turn on this right here. Yeah. Basically, if I actually let me do this, let me turn that off. Let me turn on this mesh right here. If I move the slider, you see what happens is basically it either increases or decreases the amount of pavers relative to its distance from, say, that attractor point. So these points here, let's say you take this point and you move it closer to the edge of the path, that just increases the amount of pavers that are being pulled using that. So there is nothing special about this portion of the script. It's just literally you need to create some kind of logic for how this pattern is generated. And then what we do is we take the top half and we create one color paver from that. In this case, these darker pavers. Let me see if we go to shaded view. Yeah, these darker pavers here. And then we take the second half of that split index, and then we randomly split into two groups here. Then we create the rest of that. So this index here you can play with as well. You can adjust the spacing in that. And then these are just split into two lists. So you have all these. I kind of went through this whole last step really quickly, only because again, this is not new stuff. This is the Attractor Curve, Attractor Point stuff that I showed a few weeks ago. But again, it's just a way to create a pattern on that walk. It doesn't matter how you create that pattern. So any questions about this? But that's the end of this script there is how you can create that walk.
Is there a way to use, it's more of like an attractor point question. Is there a way to use attractor point and like, I guess, loft to create kind of the same way that you were using just the variability of like distance? Is there a way to use that for height in relation to close? So like if I had this line and I had like just a straight line of hexagons that were populated on there, and if the ones that are closest to the attractor point have like a higher height value, is there a way to like loft that and basically create like I guess a gradient of heights based off of, I guess, a projection?
Yes, there's a way to do that. So let me turn off these curves here. And let's go to this step right here. This is the attractor point, attractor stuff right here. So let me actually just disable that guy. So basically at the end of this whole process, you have a list of numbers, right? And these represent the distances from the point to the paver. So you can just simply, either extrude it. I'm just going to move it vertically just to make it simpler. What you can do is you simply move the paver. In this case, the paver is in the A right here. So move that vertically using a Z vector and then put the number in there. You can see that's what it's doing right there is it's taking the pavers, is moving it vertically. That's kind of what you're sort of saying. So the closer the point is, it's making it lower. So if you want to inverse that relationship, you use a remap. So what you do is take a remap those values. Let me move this over here. Remap the the numbers which are in the K right here. Remap those values. Use a bounds. This is the same thing as the remap thing that I showed a few weeks ago. Bound that, flatten. Put that to your source domain. Then your target domain is basically just going to basically be, let's say, if it's going from small to large, you make it large to small. So I'll say 10 to 0. And then that does that. So now the closer it is to the point, the higher it goes. And this is just a move. You can also just do an extrude. I think that's what you're going for, Aaron, is extrude. I'm not going to do extrude because there's going to be a lot of things to extrude. I mean, let's just find out what happens. It's gonna maybe it'll crash, but let's see what happens. Move extrude. Yeah, it didn't crash, but that's kind of, I think that's kind of what you're asking, right?
Yeah. It was more so like for like a perimeter for seating, but this does like exactly the same thing. It actually looks a little bit cooler than what I had in mind.
Yeah. So extrusions are not capped, so you always want to cap it. So cap the holes like that. And then that is your final. Well, I like to put a custom preview onto my solids and a swatch. And that just makes it a little easier to visualize the end result. So it's kind of that's an interesting design. Grasshopper is fun. You just got to play around with it. You can come with like a weird snakes. That's what I see here as a snake shapes.
The most ADA unfriendly ramp ever made.
Exactly.
I guess I have a question to add on to this, which is rather than like shortening the length of bricks on the interior of the curves, is it possible to just remove bricks so that you can keep a uniform paver size, but have some just go missing?
You mean like right now you can see the pavers are long here and short there. What do you mean is, yeah.
And I guess another way of putting this is instead of having the run be along the spline of the path, having the run be perpendicular to the run of the path.
Yeah. So to answer your first question, like, can you just, remove pavers? That is a bit more of a complicated technique. Basically, you need to establish a run of pavers for each row, essentially. And so that requires a little bit more complexity in this. So for the purposes of today's script and for probably your project, I would not recommend going that far. Again, but the answer to your question, yes, it is possible, but it's going to create a very complex script.
Gotcha.
Anything is possible in Grasshopper, but it just depends on how far are you willing to go in terms of the complexity of it. To answer your second question, can you go in the opposite direction? Yes. So basically what you do is in this section right here, this quad, all you do is you flip the U and V. So instead of using, let's see right here. No, not that. What you do is, let me disable this guy so don't do that. So what you do is you flip the U and V right here. So instead of this going to V right there, you put that into, let me just disconnect that, disconnect that. So this one here would go into U and these would go into V. So that's what you get. And you see that looks really weird. That's because we got to adjust these numbers. Let me see. You have to adjust these numbers here. Let me do this. Let me just put a slider in just to illustrate the point. That's essentially what you're asking for.
See. Right. Yep. I see.
Yeah. Basically, just like taking the U and V and you flip it here, and then you have to adjust these numbers to make that work. So yes, what this does is it creates wedges in the script or the paper size. So it's a little bit depends on what you're going for from a design standpoint. So okay, any other question? Yeah.
So after you make your path like this and you have your pattern, when you're actually applying it, it turns out have you already applied a texture to it, or like for it to or like if you apply like a concrete texture to it, is it gonna create discoloration within that concrete in Inkscape? Like how do you apply the texture and then, you know what I'm saying?
Yeah. So it's a good question. Basically, how do you render this? So let me enable these guys here. Okay, so there we go. So these are your final pavers right here. So what you do is, let me do this in Rhino. You can see my layers right here. What you need to do is you need to create a layer for each paver color. So we'll do 3 layers. Call layer 1 dark, mid, light. And basically what you do is you take the dark pavers here and you bake the meshes onto the dark layer. So bake that there. You bake the mid pavers onto the mid layer, like so. And you bake the light pavers in a light layer, like so. So then in Rhino now, you see that the pavers are now in there. They just don't have any material associated with them. So what you simply do is you go into materials of each of the pavers here. So for instance, dark, you can go in there, apply custom texture. So go in there, go to your textures folder, find like a dark texture looking thing, go to mid, apply a mid and light, apply light texture. So you can see that's basically what you get. So you just need to bake the pavers and then apply texture to it. So if you run Inkscape now, you see what the result is. It's really easy. Oops. That's your final design. Design is fun. Design is easy if you know how to use Grasshopper. You can do anything you want. You can make your dreams come true, including creating the curvilinear paver garden. This is not too far off from a final construction document. Like, you just need to lay out the pavers and give it to the contractor, and they'll look at that and they'll go, okay, they'll figure out how to cut the pavers. They'll figure out how to align them. You just need to give them the design intent, and they'll take it from there. Good question. Any other questions? Before we move on to I think the last script, maybe the second to last script. So yeah, I mean, like, you know, this like a more in-depth version of this path could be your assignment for Graphics Studies 3. You just need to have fun with it and play with it and come up with a cool concept. Maybe combine this with maybe the tree planting script and come up with like a little garden space within your Opelika project, whatever you want to do. Maybe this is not exactly what you want specifically for you know, thing, but yeah. Okay. So let's go to the last thing and then we'll end class, which is this little thing right here. So let me go to screen wall layer. I'll turn off everything else just to make my workspace cleaner. This one right here. Okay, so this is the layer we're going to work on. This little surface here. And what I'm going to show you guys is basically a screen wall script that I worked on for a project when I worked all back. I'll show you a quick rendering of that look. It's actually built, but I just don't have any photos of it. But let me find a image of what I mean. It's one of the first things I worked on that actually got built and utilized a grasshopper thing at work. It's basically a design like this, basically a screen wall with these wood panels on them. And these wood panels, you can see there's a gradient on that wood paneling where it has like a thick to light gradient on that, and then there's a structure in that. So this is one of those things that I designed and I gave it to the client, and they just built it the next day. It's like, okay, yeah, it's easy. So I'll show you how that. And again, this is just a way you can take a simple piece of geometry like this. So in this case, a vertical surface like this, and we're going to turn that into a screen wall. And then I use an attractor curve like this to create the patterning. So the script is, let's see, screen wall v1. And, let me turn off the thing here. So I'll explain. This one I didn't quite annotate. This was probably the last one I worked on. So it's probably the least helpful, but I'll try to explain it as it goes. So first what we do is, let me move this to the side here, is we set the surface in Grasshopper using this run right here. And then we use this combination of two components right here, this divide domain component, and then this iso trim right here. What this does is it allows us to take that surface and allows us to like divide it into like a bunch of smaller surfaces. It seems like a really complex way of just saying like divide the surface into smaller surfaces. Basically, what I'm doing here is imagine that this is your screen wall and that these are all planks of wood. And so what we do is we take that wall there and we divide it into a series of planks here. And the two variables that you use to divide it is this number right here, this 10 right here. So if I change that to like say 5, you see what happens. It makes the actual wood members themselves longer. Or you can mess with this value right here. Right now it's set to it as a 2. If it's set to 1, it increases the vertical length of that. Right now it's set to 2. Basically, what I'm doing is I'm taking the vertical length of this wall here, which is this V number here, and I'm dividing it by a value. So if I divide it by 1, then these are basically 1 foot width wood panels. If I divide it by 2, these are 6-inch wood panels. This is a little bit less of an intuitive way to model the wood, but it's a way to model the wood. So these are our wood panels now. And then what we do is we take these wood panels here and we extract a center point of the panels. That's what these are here. Then we use this attractor curve to, again, get the distances from each of these points that a curve. So that's what this thing here does. Then we use those distances to basically split this list into a grouping of 3 categories of wood. So what we do is we take these sorted lists, the sorted list of distances, and we sort them using this thing right here. And then I showed this, I think, at the end of one tutorial previously, which is a way that I use to partition lists, is to use basically like these like lists of percentages. In this case, like 33, 33, 33. So imagine like I want 33% of the panels to be one thickness, 33% to be another thickness, and 33% to be another thickness. This just allows me to very quickly partition them into these lists here. So that's what this whole process is doing right here, is taking this list here and partitioning it into 3. Then we use this tool called Bang to basically take that partition list and split into 3 separate panels. So now we have group panel 1, which is this one here. Panel 2, which is the next furthest away from the attractor curve, and then panel 3, which is the farthest away. And then all we do as the final step is we simply take these wood panels. Let me turn off these here, and we scale them in the Z direction, the vertical direction, to create that wood paneling look. And then what you can do is you can simply adjust the Z factor of this to basically, adjust the porosity and the visibility of it. So you can, again, just a way that you can create that gradient look. Maybe you want to have the opposite effect. Maybe you want the middle to be thicker. You can just do that. So it's just a very simple way to create that that look. Let's make it like this. And so that's the end result, is these right here. So what I would do at the final end of this process, I will take these curves, these surfaces here, I'll create a layer called wood. And then I'll just take these layers here and I would just simply bake that onto that layer there. And then one thing I also created, if I go up here, I created these series of components here that essentially creates a structural member on the side. Again, we don't have to go into this whole thing, but basically these numbers here represent the dimension of this member here. So what I'll do is I'll simply just bake that, call it structure. So we bake that guy. Oops, let me do this. Set that to the current layer. Bake that. I didn't make the wood panels on the wood layer. So then what I'll do basically at this point with this now set up is I would take the wood right here, select those surfaces in Rhino, offset them, and I'll offset it by, say, for instance, a distance. Let me flip these, flip all. I'll do, say, for instance, half an inch. Let's do 1 inch, 1/12. So right now what it's doing is it's taking all these wood paneling and it's basically giving it thickness. Just to give it a second, because there's a lot of panels that it's doing. It'll work. There we go. And then we'll take the structure, cap that. So that's solid. And then again, what you do is you can just take these panels here and you can apply a material to it. So we'll take the wood layer, apply a material, go to custom, color, find a wood texture in our textures folder. I believe I gave you last semester, I gave you like all my textures. So you should probably have already a library of these textures, but I'll pick a simple wood texture. And then in this case, the wood is running in the wrong grain direction. So what we'll do is we'll take these here and we'll apply a texture map. Hopefully this is just a review for you guys. What you basically do is put player map, 3-point, just play a map to that. There we go. That's that. So now I can render this in Enscape. So again, this is just one way to create a screen wall. I mean, this is one design. You can obviously, maybe you don't want to use wood. Maybe you want to use like cabling and wire. That's probably a bit more of an appropriate, screen wall that wants to grow vines. But again, without a specific design concepts, this is just one way to do it. But I just want to show one example of how that could be done. So really simple script. Yeah. Any other questions on this stuff here?
Can we can combine, what is it? What is the image?
Image sampler?
Yeah. Like with this, like if
Yes.
you're using the image sampler to generate
Correct. You can use image sampler as well.
your pattern,
Yeah,
sorry.
you can do that. Yeah. Image sampler is fun. I'm just review the previous tutorial to show that, but like image sampler is just a lot of fun. That's probably my favorite component to play with, because you can like put images of people and cats. Let me close this. We'll end class in about a minute. These are all the tutorials that I had set up for you guys today, but I want to show you guys a quick example. I just remembered I wanted to share this, but I forgot to share it. I'm going to share with you guys a project that I have to pause the recording to share with you guys. So for the students who aren't participating in today's class, sorry, but I have to pause the recording now. So let me pause recording.